BroadCore is a modular construction system that is lightweight, strong, easy to ship and assemble. The properties of the BroadCore system enable a fully new approach to construction. The Avabot system is a vision of how robots will someday be building the cities of the future. The system contains 6 components that interweave robotics, artificial intelligence, virtual reality and education. The first part of the system is the virtualization of the real world. We can use satellite data, cameras and distance sensors on drones and robots, existing 3D models and other sensors to capture a virtual model of the real world. For example, we have a construction site. By using GPS data, drone scans and traditional architectural measurement tools, a map of the construction site and its environment can be created. This map can then be used to create an exact VR simulation of the construction site and its surroundings. After the digitalization is completed, the next component of the system, the actual VR platform, is used to create the architectural designs. In the VR platform, global teams can collaborate together in real time. They can use BroadCore Lego-like tools to compose and conceptualize building in the VR simulation of the construction site. The VR platform can also access project management system through web interfaces and thus can also be used for team meetings and project planning. After designs have been completed, the next component of the platform covers the client approvals, payment and marketing. Clients can experience a full-scale and interactive presentation of the building designs in virtual reality. After the client approves the designs, inbuilt blockchain technology can be used to approve smart contracts and receive payments. The created designs can be used for further marketing by giving new potential clients and a greater public and immersive virtual experience. When the designs have been approved and payments received, the parts of the buildings need to be manufactured, which brings us to the next component of the system: smart factory automatization and manufacturing. As the robots are connected to the VR platform, they can access the virtual designs and automatically manufacture the parts that are needed for the building. On top of that, we can use VR to enhance and create new factory processes. A virtual simulation of a factory and multiple robots like CNC machines, laser cutters, 3D printers and assembly lines can be created by virtualizing the factory environment. In the virtual environment, multiple robots can be simulated and trained by using AI. They can learn how to collaborate and improve the manufacturing process by using deep learning and reinforcement learning techniques. Because the process runs in virtual reality, it is much cheaper and safer than trying to train the real robots. After the virtual training is completed, the AI models can be transferred onto the real robots, so the robots can use the newly acquired skills in the real world. The system can also be used to reduce the robot development cost of new robots by building and simulating a new robot in a virtual world instead of prototyping in the real world. Humans can remotely operate robots through VR. By doing this, the robots can learn new skills from human operators by creating training data for AI. Piloting a robot from VR is a very safe way of operating large machinery. A human can look through the eyes of the robot and remotely pilot and operate the robot. He can use the robot to execute a complex task that would be hard to program with traditional methods. The task execution can be recorded and used to create training data for artificial intelligence. When enough training data is collected, the robot can learn from the data how to execute the task without the help of a human. After the parts are manufactured, they need to be delivered and turned into a building. The vision of the system is that the robots autonomously handle the packaging and shipping of the parts. As the robots can access the virtual building plans, they will also be able to assemble the buildings without human help. The last component of the system is its use in education and training. Through gamification of creative and technical processes, Young students and employees can experience fun and engaging trainings. When combining the gamification with the immersive nature of virtual reality, this will create a more exciting and engaging learning experience of architecture, design, and engineering than common learning approaches.